We have our next talk, Finding Critical Bugs in Adobe Experience Manager by Adam Kues and Dylan Pindur. Let's welcome them to the stage.
Alrighty, let's get started. Come up all good. We're going to be talking about finding critical bugs in Adobe Experience Manager. I'll get stuck right in. So just a brief overview of who we are. I'm Dylan and that is Adam. We're both security researchers at AssetNote, and this talk is going to be based on some research we did earlier this year. Just for anyone who's found themselves here and hasn't had the pleasure of working with AEM before, I'll give a quick overview so you know what we're talking about. It's a content management system from Adobe. It's quite old, at least in software terms. I think at this stage it's 20 years old, and Adobe's had it for 15 of those 20 years. It's super popular. I had a kind of a quick search online for preparing these slides to see how many active AEM websites there were. And at the moment, it seemed like there were roughly 35,000 active websites and well over 100,000 historical sites running AEM. It's used by a lot of really big brands, particularly Australian brands. So think CBA, Westpac, Woolworths. Qantas uses an AEM website. Virgin Australia uses an AEM website. I would be super surprised if most people here had not encountered AEM in the past couple of months. Certainly anyone who flew here definitely encountered one. So because it's got such a wide reach, it's a really good target for us for research, because anything we find is going to hit a lot of people. I'll give a quick rundown of why we want to give this talk and the rough what we want to talk about. So as I said, we were doing research on AEM earlier this year, and Shub's kind of mentioned this at the start of the talk, or in the keynote rather. The way we do research at AssetNote is we'll typically try and get a copy of the software, we'll run it locally, and we'll often decompile it and look through the source. And we really kind of focus in on any sort of novel pre-authentication vulnerabilities. That's our main focus when we're doing research. So it's kind of like a super in-depth pen test. We were doing this research and noticed that there hadn't been a lot of chatter in the security space about AEM in the past couple of years. There's been some great talks in the past, particularly by Mikhail Igorov, but all of these talks were 5 years ago at this point, so there's been nothing recently. So we were conducting this research, and there wasn't great documentation on the internals of AEM. So it was kind of difficult to understand how it worked, particularly from a pen test or an attack surface perspective, like where should we focus our energy. So that's what I want to talk about in the first half of the talk, is give you a rough overview of this is how AEM works, this is how it manages data and requests. And that way, if you happen to come across AEM in a pen test or an audit, you're basically just able to hit the ground running, and you don't have to fumble around for a couple of weeks like I think it felt we did. That'll be the first half. And then the second half, which is, I think, what everyone is most excited to see, and that's going over all the vulnerabilities we found. So we found, I think, about half a dozen, maybe, pre-authentication vulnerabilities, and so Adam's going to talk through those and go through some of the details. We've also written some tooling, which should be up, it's either up now or it'll be up later this week on GitHub, to help exploit some of those things we found. So that's what we're going to talk about. I'll give a little teaser so no one's able to leave for what we did find. We found 2 dispatcher bypasses. It'll become clear as we go through what that means. We found an XXE, an SSRF, stored XSS, arbitrary node deletion. So this is the ability to delete content from the website. 2 cases of expression language injection. In certain configurations, this EL injection can leak private keys or cloud service credentials, stuff like that. And we also found some content write vulnerabilities as well. So that's adding content to AEM. All of these were available pre-authentication in a stock standard install of AEM. Cool. So that's enough for the overview of the talk. Now the overview of AEM. As I said, we were primarily running the local on-premise version. However, we did test a lot of what we were doing on cloud versions as well. So I believe they're set up in a similar way, and it's kind of, everything here should be broadly applicable to both. Now, if you've worked on AEM or done any kind of research on it, you'll probably come across a diagram something like this. It's in all the previous talks on AEM as well. This is how Adobe recommends you deploy AEM. So it's kind of a load balancer and then these 3 layers of AEM. So, a request comes in from the load balancer, and the first thing it hits is a component called the dispatcher. It's just a simple reverse proxy. It does some checks, but mostly what it does is pass through the requests to the publish instances. This is what I would consider like the core AEM application, is these publish and the author instances. And they're the ones that are responsible for managing the content, responding to the HTTP requests and stuff like that. Behind the publish instance is the author instance, and this is where internal users connect to edit content, or developers will compile code and they'll deploy it to an author instance. Those changes are then replicated from the author instance to the publish instance. So the author shouldn't realistically be as exposed. What happens in practice, though, is that the author and publish instances are identical. They are literally the exact same Java application or jar file that's deployed. You just specify in a config file, run this in author mode or run it in publish mode. Or often you can run it in both at the same time. This is different to the dispatcher, which is kind of uniquely separate and runs as a separate server process. And so I'll talk briefly about the dispatcher because it's much simpler, but it does have some important security implications. As I said, it's a reverse proxy. It's typically deployed as either an IIS or an Apache module. I think all the instances we saw were just Apache modules, but looking at the code, it seems like they're compiled from the same code, and there's no major differences between the two. It provides some caching and load balancing. Going through the disclosure process with Adobe, it seems like load balancing is what they consider the primary functionality provided by the dispatcher. They don't seem to consider it a security critical component. It's mostly a load balancer, but when it comes to pen testing, it is very important because it does have one feature, and that's the request filter aspect of it. This is where the dispatcher functions as like the world's crudest WAF. I say crude because it only looks at the first line of your HTTP request. So it can only look at the path, the method, the query parameters, and the protocol. As far as I can tell, it does not look at the headers, and it doesn't look at any post body if there is one. And in practice, all the rules I think we saw for it basically only looked at the path. So what the request filter does is it looks at the path of the incoming request, and it'll run some regex rules and then decide whether or not to allow or deny it. Now, this is important from a pen test perspective because a lot of the interesting functionality in AEM is author-specific functionality or authoring-specific functionality, and so it's locked behind certain paths. So you'll often have to find some kind of dispatcher bypass to access the full gamut of Adobe's AEM's attack surface. But yeah, like I said, Adobe doesn't seem to consider it super critical from a security perspective. There's been a ton of bypasses in the past, and we've got a couple more to share with you today as well. So it should be no trouble getting past it. That's broadly how AEM is deployed kind of at the server level. To understand how it manages requests and data kind of internally inside that Java web app, we need to change tracks and talk about Apache Sling. So Sling is the web framework used by AEM. It's an open source Java framework. It was open sourced by Adobe. It was built for AEM. So I don't know if anyone else is actually using it other than AEM, but it is open source, so you can go have a look if you're really masochistic, I guess. As a web framework, it's kind of interesting because it's super obsessed with this idea of resources. It's kind of like they really got on the REST bandwagon a few years ago, and everything in Sling is a resource. So we're talking, web content, web pages, JSP pages, images, Java servlets are considered resources. The configuration is accessible as a resource. Yeah, they're really obsessed with it. Most of these resources come from one of two locations. They either come from OSGI bundles, so this is just like a jar archive in a specific format that's been deployed to AEM, or more commonly, they are stored as nodes in the JCR, which is what I'll talk about next. So this is an important part of AEM. The JCR is the underlying data store or database used by AEM. It's the Java Content Repository specification. I think anyone can go and implement a JCR. There's like a couple of them. AEM uses one called Apache Jackrabbit Oak. So if you're ever doing any work on AEM and you see Jackrabbit or Oak or JCR, which they do use all the terms interchangeably, just know that, yeah, it's all referring to this one thing, which is this data store or database. So it's a structured data store, and it's structured around this idea of there's a tree of nodes, and the nodes have, data and properties associated with them. It's important to remember that it is not a file system because it looks a lot like one because, the nodes get given names like index.html and there's a root node that is just a slash and you address the nodes with a path. So if you went /content/index.html, you'd be able to look up that node. But yeah, it really is just a database. There's no file on disk called index.html and there's no folder called content. They're entries in that database. I think this was definitely a source of confusion for me when we first started on our research, but yeah, it's important to remember. As I mentioned, AEM uses the JCR to store a lot of the content that it serves up and a lot of the configuration. So you can see in the example, there's a index.html in there. There might be a JSP file or something else, or like some CSS. You can see on that top branch on the slides, there's settings are stored in there as well, or so you can imagine like mail server credentials or some cloud service credentials will be stored in properties on one of those nodes. Kind of interestingly enough, usernames and password hashes are also stored in the JCR. So I don't know if this is the greatest security design where you have your username and password hashes stored on nodes that are served up in the same way that your public website is. But certainly by the time Adam and I got to it, it seemed like they'd like duct taped over everything with a lot of access control lists, and we couldn't like immediately read all the password hashes and stuff like that. But I think it has been an issue in the past. So that is how AEM stores data. Next, what we want to look at from a pen test perspective is, how is that data then served up to a browser? How does Sling handle request routing? I think a lot of web frameworks, it's relatively straightforward. Usually you'll have like a controller with some methods, and you'll tag the method with a little attribute that says this path, And so, a request will come in, and the web framework will instantiate the controller and call the method on it to handle that request. Sling is quite different, and if I'm being honest, much more convoluted. It has this kind of multi-step lookup process, and it's kind of hard to explain, but I think it's best explained with an example. So the example I've chosen there is /libs/granite/csrf/token.json. So if you see a request come in, that URL's come in, what is Sling going to do with that request? The first thing it's going to do is it's going to try and extract what it calls the resource path part of the request. As I said, they're obsessed with resources, and so this is how it does that. There's a whole set of rules for how it manages a URL and turns it into one of these resource paths. But for the example, I've chosen one that's nice and simple. All it does is it drops the .json. So you're left with just, libs/granite/csrf/token. Sling's going to take this path and it's going to use it to look up a resource. Now, as I said, this could be something from an OSGI bundle, like a Java servlet, or it could be a CSS file or something like that. In the example, it corresponds to a JCR node. So you can imagine, there's in the JCR, there's like a little libs node, and under that a granite node, and then a CSRF node, and then a token node. So it looks up that token node. And at this stage, I think a normal web framework would be done, but Sling has to be different. At this stage, Sling still doesn't know how to handle the request. To actually handle the request, Sling then looks at a property on that node to figure out and do a secondary lookup. So typically the property is Sling::resource type. It's just like a key value pair. In the example, it's granite/csrf/token is the resource type. Sling takes this property and it does a second lookup, and in the example that resolves to the CSRF servlet. So this is a case where the first lookup was a JCR node and the second lookup was a servlet from an OSGI bundle or a jar file or something like that. Now, where it gets kind of extra confusing is scripts and servlets are considered resources as well. So you can be in this odd situation where that first resource path resolves to a servlet. Even though it's a servlet, Sling still looks at the resource type on it and does a second lookup. And that second lookup will often just resolve to the same servlet. So it looks at the same thing twice. So yeah, it gets a bit confusing and stuck into the weeds when we go down into it. What this means from a pen test perspective depends on kind of how you're approaching it. If you're browsing through the JCR, there's like a little database browser tool they have. It's quite straightforward to navigate and test a lot of this because it'll just print the path of the JCR node. And you can copy that straight into Burp and then execute the request. So if it's like a JSP page, that's probably how you'd approach that. But as we were auditing a lot of the code, we're going through all the servlets, and in that case, it's a bit trickier because the servlet, it is not always immediately obvious what resource path the servlet is mapped as. So I'll talk a bit about that now. As I said, in Sling, everything is a resource, and servlets are no exception. And so they all need to be addressed via a resource path. And that's done in true Sling fashion in about half a dozen different ways, but they fall into broadly these two categories. So what you'll do is you'll either annotate your servlet with a path annotation or a resource type annotation. The path annotation is usually the simplest to manage. If you look on the example there, we've got /bin/bulk operation. The servlet tagged with this will just get mapped as a resource at that path. So you can basically just copy it straight out of the code and into your web browser or burp, and then execute a request that'll hit that servlet. So it's nice and simple. The bypath ones also tend to have fewer access controls as well because they don't go through the JCR, and that has certain restrictions. By resource type is a little bit more complicated. You'll notice all the resource type ones there don't start with a /. They're all relative paths, so you can't just copy and paste them into the browser. I find the best way to work with the servlets annotated with this is they'll usually correspond to a JCR node that has the same resource type or the listed resource type. So it's really easy the JCR has a SQL query-like language. You can basically ask it, just give me all the nodes that have this resource type, and then paste in whatever resource type you get out of the decompiled Java source. That'll give you all the JCR nodes. You can copy the path of one of them, paste that into burp. It'll look up the node, find the resource type, and then look up the servlet you're trying to test. So yeah, bit of a runabout, but still not super crazy, hopefully. That's kind of everything I wanted to say about request routing in Sling. It's certainly one of the more complicated frameworks I think we've encountered in our time at AssetNote. But on the topic of code auditing, because we're going through a lot of these servlets, there's one thing that I think is worth giving extra attention to in the context of, if you're pen testing AEM, and that's this idea of service resolvers. So in all the examples I've given before of, these resource lookups and then getting the type and looking up other stuff, this is all happening behind your back by the framework. You don't have a lot of control over what's happening. However, there are situations where a developer may want to look up additional resources like in the method body of a servlet. You can imagine a use case for this is there's some configuration node that the developer wants to access. It's got credentials or something on it. So in their servlet, they want to look up that configuration node, read the properties off it, and then use them to do something else. Or they might want to save some configuration to one of those nodes, or they might want to save content to a node if they're editing it. So usually when these additional lookups are done, they are done in the context or the same user context as whatever is executing the request. So if you're the anonymous or guest user and you're executing a servlet, and then that servlet decides to look up additional things in the JCR, it's going to do that with the same permissions as the anonymous and guest user, which is not a lot. So you can see how this is a bit restrictive. Sling provides a couple of escape hatches for this. So this allows a developer to switch context to typically a service account, and then they can use that to do additional lookups. So the three method calls that it's worth paying attention to are get service resource resolver, get administrative resource resolver, and get resource resolver, but you pass in some credentials. If you see any of these method calls, it's worth noting that this typically involves a context switch, and so there's a potential there for privilege escalation, or at the very least some kind of lateral movement to a different user. We definitely make use of this in a couple of the vulnerabilities we found, and it seems like not a lot of attention is given to it on the AEM developer side, and how security sensitive these may be. So it seemed easy to misconfigure them basically, and accidentally then pass user input into one of those resolvers, and basically just allow the anonymous user to look up whatever they want as that service account. Worth paying attention to if you're on a pen test for AEM. Cool. So that's everything I had on how AEM works and some of the things you want to look out for if you're doing a pen test or a code audit. I'll just briefly go through. This is It's not the exact process we followed, but we kind of jumped around a little bit. But I think these steps provide a good starting point if you're going to pen test AEM. They provide a nice ramp up of difficulty where it starts kind of easier and gets more complex. So you're not jumping right into the deep end with no idea how any of it works. We started the research by looking at all the servlets tagged with a path. As I said, it's the easiest way to get started because you just copy the path into burp and then you're executing the servlet. You can test it, fuzz it, do whatever you want. So we went through all of these looking for, your classic OWASP top 10 type vulnerabilities, making sure user input was validated, output was sanitized, there was no XSS or file writes, that sort of stuff. We went through all these servlets, then when we exhausted those, we moved on to all the servlets tagged with a resource type. Again, it's the same process, looking for the OWASP top 10 and whatnot. But we do these second just because, it's a bit fiddlier. You kind of have to know, there's this JCR, I need to look these things up. Sometimes you have to play around with the path to actually call the servlet, so it's a bit trickier, and I think it helps to start with these once you've kind of got your teeth stuck into AEM a little bit and you've got your footing at least. After that, we moved on to all of the JCR script files. So we basically queried the JCR and said, give me every node you have that has one of these extensions, because all of these extensions are executed dynamically on the server if you request one of them or you request a path that ends in one of them. So you've got HTML. Sling actually includes its own custom dynamic HTML scripting language called Sightly, so even a HTML page could lead to RCE, I guess, in AEM, which is kind of wild. ESP and JSP, so Java server pages, both of those are the same thing. I think that's pretty classic for a lot of Java web app pen testing. ECMA is kind of, again, a little bit interesting, so that's a JavaScript file. So if there's a file stored in AEM with the ECMA extension, Sling will also dynamically execute that on the server at runtime if you call it. It uses the Mozilla Rhino JavaScript engine to run that, which again is crazy. And perhaps weirdly enough, if you just put a straight Java file in the JCR and browse to it in the web browser, Sling will dynamically compile it for you and execute it at runtime, which is absolutely bonkers. But thankfully there weren't too many Java files, I think, in the default install. But yeah, again, we just went through all of these script files, making sure that everything was validated and sanitized and basically above board. And then the last thing we kind of looked at or gave particular attention to was those service resolver method calls I mentioned. A lot of them were probably covered in the servlet run-through, because a lot of them are called in the servlet, so we would have come past a couple of them. But just because they seemed so easy to misconfigure from a Sling perspective, I think it was worth giving extra attention to them, and we basically just grepped for every instance of one of those method calls and then checked each one to make sure that all the user controllable input flowing into them was validated. Cool. That is, it was meant to be an overview of AEM, but it really kind of ended up being an overview of Apache Sling, so I don't know if you'll consider that a win or not, but that's how it goes. I will now hand over to Adam, and he's going to talk about what you're probably all more excited to hear about, which is, all the fun vulnerabilities we found. Take it away.
Perfect. So with an understanding of how AEM works under the hood, let's take a look at what we found. So we're going to start with dispatcher bypasses, and as Dylan mentioned, in terms of a pen test context, dispatcher bypasses are probably one of the most important things. And the reason is that without having any dispatcher bypasses, we basically cannot use any AEM payloads or exploits. Without a bypass, we would send something, but if we're sending it to the wrong path or a path that's blocked by the dispatcher, we would just get a 404 back. So having a dispatcher bypass is crucial to do any further exploitation. When conducting this research, we had a lot of AEM targets in mind that were using the cloud environment, AEM Cloud. So to start hunting for bypasses, we cracked open the source code, not of AEM Cloud itself, but of the AEM Cloud dispatcher. So specifically the dispatcher that runs in front of AEM. And the idea was that even though AEM deployments are very often very custom, usually companies are not going to be toying with defaults. Maybe they're going to add some configuration, but the configuration that's in the default, they're probably going to leave that there. So I've included on this slide 3 lines from the Apache configuration used to power the AEM dispatcher. And what this is doing is this is actually an exception to the dispatcher. So the dispatcher is not a proxy in itself. It's just a module that runs on something like Apache or IIS, which means if Apache decides to route the request without going through the dispatcher, we don't have to worry about the dispatcher at all. And the intent of this specific 3 lines of code is to ignore the dispatcher for this particular route, /GraphQL/execute.json, followed by anything. And to start with, this doesn't really seem like it should be a problem. None of the paths we'd want to access as a pen tester have this at the start. But what caught our eye was this no cannon flag, which I've highlighted in yellow. I'd never seen this before. I did not know what it does. So I looked it up. And according to Apache, what this flag does is that it instructs Apache not to normalize the URL before doing our location match. So this can be a bit hard to understand, but I've prepared an example. So here are 2 location matches, which are very similar to what we saw on the slide. And the intent is we're only allowing through paths that start with foo. Very simple. So in the first one, we haven't used the no cannon flag. This is the default behavior. So if we're a bit malicious and we try a URL with a path traversal in it, such as /foo, path traversal /bar, the default behavior of Apache is to normalize that, realize that really what we're requesting is /bar, and saying this doesn't match, I'm going to go on to the next rule. However, with the no cannon flag, Apache has been instructed not to normalize the URL before doing the match. So in this case, it doesn't resolve the path traversal, and it decides that our path starts with /foo, and it's going to pass it directly to AEM. So we can pair this quite simply with the rule we saw before by just simply traversing out of this endpoint. So we go GraphQL, execute.json, and then we traverse out twice, and then we can call any AEM URL we like. In my example, I've used bin query builder, which is often used to sort of leak sensitive information, but really this can be used for anything. And this works by default on all AEM cloud deployments. And as an aside, when you look up this flag in Apache, it has a little security note in a little red text box that says something along the lines of, this flag could cause security issues, so no kidding. So we had discovered one bypass, and we found that it worked on a fair few hosts, but not all of them. I mentioned this was part of the default cloud deployment, but there are also a lot of on-premise instances of AEM, and they do not have this code in them. So to exploit these other instances, we're going to need something else. We're going to need something in the dispatcher itself. So to understand the dispatcher better, I've actually included on this slide some default configuration from the dispatcher. The dispatcher has its own sort of like mini language to do its firewall rules. And so, as Dylan mentioned, each rule starts with a rule type and then either allow or deny. But then we can filter things like the method, the extension, the path, or even like a full URL or something like that. We can also deal with the query parameters, although this is not often used. And a natural question to ask is how does the dispatcher actually parse the path into its separate components? Like we can start thinking about ideas like, oh, if we include multiple extensions, which one's it going to take, and things like that. Because the dispatcher can't really parse the path in the same way as Sling. Sling is a Java application, and the dispatcher is like a compiled C or C++ module. So the dispatcher doesn't really have any way of emulating Sling perfectly. So the solution that the Adobe Experience Manager devs came up with is to re-implement parts of Sling parsing in binary, in C, and compile it into the module. And this gives us an interesting angle because if we can find a differential between what Sling is parsing a URL as and what the Apache dispatcher module is parsing a URL as, we might be able to get a bypass. So from that, we had a look at a very obscure feature of Sling called path parameters. If you've done any work with Java before, you may have seen bypasses that use a similar technique with Tomcat. This is not the exact same, but it's a similar idea, and it all revolves around the idea of this semicolon. So here we're making a request to our AEM host, and it's just a bin querybuilder.json, but then we've tacked on a semicolon and this x equals hello on the end. Now what is this? Sling parses this as a path parameter and it's essentially ignored. It's supposed to be used for extra information that you need in a request, but in practical terms, it's almost never used. It was introduced in about 2018 or 2019, but it's not really well covered in documentation. I think most developers don't know about it. So our thought was, if you're a developer trying to re-implement Sling parsing, say for a dispatcher, and you were trying to figure out all the ways that people could call your functions and stuff like that, maybe they would forget to implement this feature. And it turns out that's actually the case. So AEM's dispatcher does not know about path parameters, and it takes a semicolon just as a literal character in a path. So we can now achieve a differential with this. So I've prepared a URL, which is the exact same as on the previous slide, but instead of having hello, we have this weird construction x/.ico/y. Now, when the dispatcher looks at this, it's not going to consider the semicolon a special character at all. So it's going to parse everything greedily in the path up until .ico, which it considers to be the extension. It then sees some stuff after the extension, which it just discards. It's known as a suffix. The dispatcher will look at this and say, well, this is a .ico file, and .ico files, they're an image file, they're typically safe. I reckon we can serve this to the user. We're not going to block this. When Sling then sees the exact same URL, which has been passed from the dispatcher, it's going to go, hang on, this is just bin query builder.json, so now we're requesting a .json file, and it's going to ignore everything after that because it's all part of a path parameter. And so looking back at the default configuration, we see that there's this allowance for various CSS, ICO, GIF, JPEG, things like that. By default, we can request any of those on a system in a default installation of AEM, as long as it's a GET request. And so by tacking on this path parameter, x/.ico/y, we can fool the dispatcher into thinking all of our requests are requests to .ico files, and we get a full bypass in a default installation of AEM. So as we were discovering these bypasses, we were testing them on real deployments. Because as we've mentioned several times, AEM is often quite custom. So one problem with pen testing AEM is you may find something that works in the stock deployment, but you may find that practically it doesn't seem to work very well because companies have heavily customized it. And one problem that we consistently had was that our first bypass seemed to be working, except we were getting blocked by a Cloud WAF in front, something like Cloudflare or Akamai. And the reason for this is pretty simple. Our first bypass required a double path traversal in the URL, and this is obviously incredibly suspicious. So the Cloud WAFs are right to block this. So it became then our job, well, can we reutilize that first bypass in a way that doesn't involve any traversals? It's not so easy to get around because we can only really toy with the path. So we looked back at this location match, and actually I've included just this single line, and there are actually 2 vulnerabilities just in this line alone, which we missed the first time we looked at it. So I'll just give you a couple of seconds to look at that one line and see if you can spot anything that's sort of sus. So the first thing is that this is a regular expression match. And so the dot in execute.json is not matching a literal dot, it's actually matching any character. So in fact, we can do GraphQL/execute_xJSON, we can do GraphQL/execute/JSON, anything, and it will still match. But the second and more egregious vulnerability here is that this regular expression is not anchored. We do not have a caret to match the start of a string, and we do not have a dollar to match the end of the string. The practical result of this is that this location match is actually matching a substring anywhere in the URL. So we do not have to have GraphQL at the start, we can have it anywhere in the URL. Now, do we know of a feature where we can stick random stuff anywhere in the URL and not have it parsed by Sling? It turns out we can. We can just use our semicolon trick from before. And indeed, this is a much better bypass than the first one because there are no traversals. There's nothing suspicious to a Cloud WAF. And we had a lot of success with this one. When we reported these to Adobe, Adobe has pointed out, as Dylan said, that their official position is that dispatcher bypasses are not considered security vulnerabilities. Because even though a dispatcher has a firewall and a set of firewall rules, they consider the dispatcher as intended as a load balancing and caching tool and not a security mechanism. So the benefit for you guys as offensive security professionals is that even though we have reported these still work in the latest version of AEM, both on-premise and in cloud. So now we've gone over some dispatcher bypasses, let's go over some vulnerabilities in the core of AEM itself. So to exploit these, we're going to need to pair one of our dispatcher bypasses, which I talked about previously, and then exploit some of these endpoints, because we can't access them usually. So one thing about this presentation is that even though we present how it works first and then the vulnerabilities we discovered, in reality, we were hacking AEM at the same time we were trying to understand it. So a lot of our early research was done on the easy stuff, such as like path-based servlets, which was more familiar to us looking at a typical Java code base. And this is one of the first vulnerabilities we found. It's pretty much a textbook, straightforward SSRF. It's a servlet that takes two parameters. The first is optional, it's a subscription key. We can ignore that. The second is an authentication URL. And then it does a post to that URL and just gives us back the content. There's no checks for localhost or things on the local network. And so we were pretty easily able to come up with a POC for this. We simply post to this endpoint with the auth URL, and in the response, we get the full content. So basically a very easy full read SSRF. The only limitation of this is that it does do a post and not a get. So whatever internal network or internal resource you're trying to exploit, it must accept post requests. Something that's a little more complicated, but still we found on quite early, is we found that with a dispatcher bypass, we could access this interesting screen. So this screen is part of the CRX package manager, and it seems to be intended to be used by administrators. One thing we noticed we could do was view this page, and we could also seemingly use this upload package button, which I've highlighted in red. You can think of a package almost like an extension. So the format is complex, but it's basically a zip file that's filled with executable code and XML, which describes the format. Obviously, if you're uploading something that contains executable code as an extension, its legitimate use is to add new features to AEM, add new endpoints, stuff like that. But if we were able to upload our own extension, perhaps we could get RCE from that. Unfortunately, we found that the upload fails due to no permissions. So even though we have the dispatcher bypass, we're still an anonymous user. And by default, anonymous users cannot write anywhere on the file system. They can't write any nodes. And that definitely includes the apps directory where all the extensions are stored. So we can't just upload a package and get remote code execution. That would be way too easy. However, what we did notice is that the upload functionality seemed to work, and it did seem to do some validation before trying to copy the file into the directory. So we upload something, AEM does some validation to make sure that the extension is correct, and then it tries to copy it into the directory, which fails. So if we're able to find some issue with the directory itself, or with the checking itself, the validation of the XML, maybe we could find a vulnerability there. And because these are zip files that are filled with XML, a natural question to ask is, well, maybe there's an XML external entities attack. So I've included a small amount of code on the slide, which is used as part of the validation routine. The interesting part of this is it uses a default document builder factory, which is something in Java used to parse XML. Now, if you've done any Java analysis in the past, you'll know that still, as of 2025, by default, if you use a document builder factory, it's vulnerable to XXE attacks unless you set specific flags. In this case, these specific flags are not being set, and so we can actually get an XML external entities attack. So here's how we constructed it. A minimal extension only has two things. It has a JCR root folder with at least one file, but the file can have anything in it. And the second thing is that it has this privileges.xml where we're going to exploit our XXE. And in my case, I just put a simple callback to my Burp Suite collaborator instance, and I was able to verify that we did in fact get a ping back to our collaborator instance when we uploaded this extension, despite being an anonymous user. So we got an XXE. It turns out this is actually a vulnerability in a dependency. Dylan mentions Jackrabbit, which is the content repository system. That's actually where the code is from, but it actually affects AEM as well. So the CVE for this one is actually tied to Jackrabbit and not AEM. When we found this, we got very excited because if you know anything about XXE, it's often considered a critical vulnerability. And one of the reasons for that is it's supposed to allow us to read local files. There is a problem in this case though, and that's a blind XXE. So when it parses the XML, we don't actually get the response back. We only get either a yes, it succeeded, or no, it didn't succeed. And of course we can do HTTP requests to ping back to our collaborator server, but we can't really leak much. And due to Java's modern protections, because this type of vulnerability is so common, the best thing that I'm aware of that you can do is leak the first line of any file on the file system, which is cool, don't get me wrong, but we did look at the file system quite extensively, and there's not much actually stored there in terms of like secret keys or anything that would be sensitive that's exactly on the first line. So this is a cool vulnerability, but we remained on the hunt for something super critical. So as we read through more of the AEM source, we found multiple promising avenues for exploitation that involved AEM parsing existing nodes or content. So those are things that authors would usually upload. It can include images, it could include HTML pages, it can include templates in some cases. The problem was that as an anonymous user, we don't have write access anywhere on the file system by default. So we can't write to any nodes anywhere in JCR. If we were to continue looking at these paths to exploitation, we really needed a way to write nodes to somewhere that we know about pre-authentication, which is not supposed to be possible. We came up with two solutions to this problem. The first one is just to rely on customers misconfiguring things. So if you've been on a pen test before, perhaps you've found a cloud bucket that's accidentally been made world writable or something like that. This is a very similar principle. We're relying on the owner of AEM. Maybe someone gets frustrated with the permission system and actually accidentally gives star access to write a specific node or something like that. It's actually quite common. Luckily, we have a very easy way to search for this using our dispatcher bypass and this bin query builder.json endpoint. I've just included the URL here. Most of it's not important, but the thing that's doing the heavy lifting is this has permission. And there are actually 3 permissions that allow us to do this right. The first one is if we can overwrite something, so if we have write permission. The second one is if we can add child nodes, so we can add nodes under a directory or something like that. That's also a common misconfiguration. And the third one is if we can modify the properties of the node. So not the content of the node itself, but just its properties. And in many cases, it turns out to be enough. So this is obviously cool and all, but we're really relying on the developer, whoever's maintaining the AEM instance, to screw up. Can we do better? Can we find a way that works in a stock standard install? And it turns out we can. So Dylan mentioned this very dangerous function, get service resource resolver, and it actually came in handy here. So you can think of this get service resource resolver almost like the pseudo equivalent for AEM, where we're temporarily changing to another user's permissions to do what we need to do. What this servlet allows us to do, pre-authentication, is assume the role of this create rendition user, which does have permission to write in some directories. And what this servlet will then do is it will take our file upload, which can have arbitrary content and arbitrary properties, and put it in this specific directory inside the configuration directory. So when all is said and done, this allows us to write to this specific file path. However, there is one problem. And the problem is we cannot read the nodes back that we just created. The reason is quite simple. We had sudo when we were writing it, so we assumed the role of create rendition user. But when we try and read that node back, we're reading it as the anonymous user again. And the anonymous user, of course, does not have permission to read configuration files. So we can create files, but we can't really read them back, which, might be interesting, but it's not super useful. We found a solution to this problem as well with another get service resolver call. So there's yet another servlet, which is in AEM by default, where we assume the role of a different user. This is the context hub conf reader user. And this user has a lot of permissions for various directories, but for us, we're interested in, can we read the things we just created in the conf directory? So we looked at what permissions we were granted as this user, and I've included the important things in green at the bottom of the slide. So within the configuration directory, this user has permission to read 2 types of things: nodes that are called exactly the word cloud settings, or files in a directory named cloud settings. Now, if you recall, we can't actually create directories, we can only create files, and there was no path on the file system there was no directory on the system called cloud settings, so that seems a dead end. But what happens if we name a file exactly the word cloud settings? So this is actually what we ended up doing. So it's a 2-step process to get this node right to work. First, we post to the servlet with any content we want. So we're writing any content we want, including images or a HTML file or something like that. And we call the file exactly cloud settings. So the name we're uploading is exactly cloud settings, and we fill it with whatever content. Then, when we read it back, we assume the role of this different user, which has permissions to read files that are named cloud settings. And so we're able to read it back like this. So what can we do with this? We have another problem, and that because the file is exactly named cloud settings and cannot be overwritten, we thought that we only had one shot at this exploit. We can't vary the case or anything like that. So once you uploaded the file, once you've burned a certain AEM target by uploading this file, we thought we were done. It turns out, thankfully, that this is not the case, which was useful for experimentation purposes. But in fact, it's a temporary directory which is only cleaned every 6 to 12 hours. The practical result of this is we really only have one exploit attempt every 6 hours or so. And we're impatient, so we want to get the maximum impact possible out of this pre-auth file right. So what do? We quickly found that there are some node types that lead to a stored cross-site scripting vulnerability, so we could pop alert boxes on AEM, but we wanted something better. We felt like there should be something better. So I did mention before that there were some node types that allowed you to evaluate templates. And we did find one quite quickly. The code on this slide is not super important, but the important part is this action parameter, which is a parameter that we can specify. It's a property on the node we upload. And what this code is doing is that it takes it and then evaluates it as a Java expression language injection. So without thinking too much, we tried our simple template injection payload, and we saw that we were able to achieve a template injection. 7 times 7 was turned into 49. And we got super excited at this because usually expression language injection, if you've ever dealt with it before, or separate types of template injection, usually this is equivalent to RCE. However, there was yet another problem. And the problem was that Adobe was aware of this, and they had implemented some restrictions on what we could do with inside this templating language. So we quickly checked what we could and couldn't do. We first noticed that, of course, we could do arithmetic because 7 times 7 was equal to 49. That worked. We also saw that we could do property accesses, so that any variables that applied on the page, and there are also some default ones such as page context, we could read their properties, which is cool. We could also saw that we could do array indexing, so we could declare arrays and index into them. We found, however, that the valuation does not allow us to do any function calls. So any ideas we may have had of calling system or calling into a shell or calling any other dangerous Java methods, those hopes were quickly dashed. And we really looked hard, and there's really no way to do this. The second thing that it blocks is we can't actually set any properties. So one idea we had is maybe we take our session and we can set it so that our name is admin or something like that. Turns out we can't do that either within this very limited template language. So what's the maximum impact we can get if we just have property accesses and array accesses? Well, it turns out that AEM stores all its configuration not only in the JCR content, but also for efficiency in memory, in objects in memory. And it just so happens that there's a chain of property accesses that we can do to traverse from the object that we are given all the way into these configuration objects. So here we're using the fact that everything is in a bundle, an OSGI bundle, and each of those bundles has one or more services, and each of those services has its own configuration. And we can essentially toy with the two numbers here to consecutively leak all the configuration for every single service in AEM. So essentially a total leak of all the configuration secrets in AEM. And once we started toying with this on real targets, we started seeing stuff like this. So this is a Azure private key. We've got an account name and an access key there. It was obviously configured for some integration where maybe they're syncing their page content from Azure from like a different thing, because AEM has lots of integrations like this. But we were able to leak this pre-authentication. As we continued, we found more and more stuff. Administrators obviously don't expect you to be able to leak all their configuration, and so there's lots and lots of sensitive stuff stored in there. We saw certificates, we saw admin hashes, and by the way, if you can crack an admin hash, sometimes you can get remote execution, code execution that way. We saw API keys for all sorts of services, and basically anything they store in their configuration, we can leak pre-authentication. So to summarize, by combining a dispatcher bypass, which we talked about at the start, the pre-authentication node write, and then this expression language injection bug, we're able to leak the complete configuration of AEM, including all secrets. So no presentation like this would be complete without some tooling, and we are actually releasing some tooling either today or very soon. Our tool is called Hobgoblin, and it basically automates everything that we've talked about in this talk. So it auto-tries the various dispatcher bypasses that we've talked about here. It checks for the XML external entities attack. It checks for the SSRF. It checks if it can write nodes. And if it can write nodes, it checks maybe if we can use that to get EL injection. It's already found countless exploitable instances in the wild, like tons and tons of them. We were running this tool and developing it during our research, and it does really work. But the most important thing is that it's configurable. So a lot of AEM instances are custom. Maybe they have rules which block our specific attacks, but if you modify them slightly, if you modify the dispatcher bypass slightly, maybe by choosing a different extension or maybe by tweaking the path a little bit, you can achieve another bypass. So the tool allows you to do that as well, and it will be available at this URL. Here's a simple output from the tool. Essentially, what it's doing is it's querying a lot of different endpoints. It cycles through the dispatcher bypasses we have. If it finds one that works, it reports it, and then it starts trying to exploit the good stuff, such as the expression language injection. So in summary, these vulnerabilities were fixed, with the exception of the dispatcher bypasses, which are not considered security vulnerabilities by Adobe, in this specific hotfix, which happened about a month ago. This means that all cloud versions of AEM already have these patches, but AEM, people on-premise have been known to be slow to patch because they think the dispatcher protects them, so there's still plenty of exploitable instances out there. AEM is an incredibly popular software with a lot of bugs still, and we found working at Asset Note that the main barrier to understanding AEM and hacking AEM is how convoluted everything is. The JCR node system, Sling, and the permission system. They're all very complex and they're all very alien compared to typical Java applications. So hopefully in this talk, we've been able to sort of give you a running start if you ever want to look into AEM yourself, how to understand the various components of AEM. And hopefully you can use some of these bugs on your next AEM target. Thank you.